Good evening. I'm Nick Bax from CSIRO Australia and co-chair of the Global Ocean Observing System Biology and Ecosystems Panel. I'll just share my screen with you. Thank you for the opportunity to talk to you at your Ocean Sites meeting today, and hopefully by the time you're listening to this, I will be asleep. But my co-chair, Gabrielle Canonico, is awake and will be available to answer questions at the during the discussion time. Just briefly, the Global Ocean Observing System has 3 expert panels: physics, biogeochemistry, and the Biology in Ecosystems panel, which is the most recent one. We share with the other panels global observing networks, regional and national organizations, so we're very much part of that GOOSE family, and also share in project development such as Atlantos and DOOS and other areas like that. What distinguishes us from the other panels is that we do primarily work in delivering the area of ocean health, although of course we also contribute to the biological component of climate change. The panel started about 6 years ago, and we had to really decide what were the essential ocean variables which we were going to use for the biology aspects. And building on the framework for ocean observing, we recognized that that met a very commonly used biological model, perhaps one of the few commonly used biological models, in this case, the driver pressure state impact response model. And so we first of all needed to work out what were the drivers and pressures which were most important for society to report on. So we reviewed 24 different international conventions and agreements and worked out which particular aspects of biology were most commonly reported or need to be reported by countries to those conventions. Then we started looking at the status of observing programs, which observing programs were in existence and looked like they were scalable, they could be increased to become a global observing program. And also, which one of the variables which seem to come up in the international conventions, which some ones were clearly linked to pressures and impact, so that we knew we were looking at variables which would have that impact on management and policy response. And finally, understanding who we do report to, and we report through the IPCC, through GCOS, the CBD, through some of the essential ocean variables, especially coral at the moment. That's got relevance for the Sustainable Development Goals. We also work very closely with the Marine Biodiversity Observation Network under GEOBON. OBIS is our main data delivery group for these EOVs, and we're also, the EOVs are now gradually being displayed also by UNEP World Conservation Monitoring Center. What are the essential ocean variables for biology? We have 6 in functional groups: microbes, phytoplankton, zooplankton, invertebrates, fish and turtle, birds and mammals, and then also 4 which recognize particular habitat states. And interesting to notice that those habitat states are primarily coastal habitat states. And we also have essential climate variables which we report on through GCOS, and those are the essential ocean variables organized into 2 different groups, one which is plankton and the other which is marine habitat properties. There is also quite a bit of overlap between our panel and also the MBON panel, and so we also have a quite link. We understand that if we can achieve suitable measurement of the essential ocean variables, that we will also be able to measure and report on the essential biodiversity variables. As I said before, we give our information through OBIS and work on Darwin core standards, and working with the Ocean Best Practices portal for endorsement of best practices which meet the GOOSE EOVs. As part of a Pegasus project through NCEAS and Future Earth, we spent quite a bit of time looking at all the long-term biological observing programs around the world. By long-term, we mean in this case they've been measured at least 3 times, and at least one of those times has been in the last 5 years. So perhaps not very long-term, although some of them, like Continuous Plankton Recorder, have been around for more than 100 years. This is the map in a paper in preparation of 192 observing programs, and perhaps sadly to say, if we look at observing programs which have measured at least 1 EOV in each half-degree grid of the ocean, our coverage is approximately about 6% of the ocean. So there are vast areas of the ocean which are not being monitored currently for biology, and I think that's an incredible opportunity for ocean sites to engage in, to start filling in some of the big gaps we have, especially in the open ocean. What are the prime opportunities we see at the moment? I think there are 2. One is in the area of plankton. Of course, we have synoptic satellite recording for plankton, but it's quite clear that the satellites only look at the surface. There's a lot going on down in the water column, and we get dramatic improvements in predicting or measuring net primary productivity if we have those subsurface measurements. It's a 50% at least increase in precision of the estimates of net primary productivity. And there is an existing SCORE working group which has already come up with recommendations for how plankton measurements could be easily incorporated into the existing GoShip monitoring program, and they're also now turning their attention to how plankton could be incorporated into the ocean sites platforms as well. And I think it needs to be said that it needs to be more than fluorometry. We have fluorometers on BioEcos. It's a great start, but it's really not sufficient to understand what we need to know about productivity below the surface of the ocean. And there are new technologies being designed, which we hope will soon be available. Lastly, it seems there is a link, potential link to the deep ocean observing system through cabled observatories. So that may be and indicate where perhaps some ocean sites may be most relevant. The other area which is of interest is the idea of passive acoustic measurement. Ocean sound has recently become a Goose Essential Ocean Variable under the International Quiet Ocean Experiment. And currently, passive acoustic monitoring areas are limited to either cabled observatories, which are close to shore, or also passive acoustic networks through the Comprehensive Test Band Treaty Organization, of which there are 5. And they're low frequency and typically will not be easily available to the scientific community. So there's an opportunity to establish ocean sounds and indicator of ocean health, and for measuring the heat budget. And there's a gap in ocean sound, especially near the polar regions. We were asked over the next 10 years, when would you call us? When should we call you? We would like to call you once the SCORE working group have completed their deliberations and worked out how plankton can be added successfully to the ocean sites platforms. We'd like to also contact you once we have new technologies available for long-term deployment on in-situ platforms, such things as an underwater video profiler for measuring plankton species and size, an in-situ DNA sequencer to measure eDNA and get a comprehensive list and abundance of species in the area of the ocean. And also, as we are over the next 10 years developing UN decadal projects, that would include ones in current development, an eDNA monitoring program in association with POGO. We're interested in a pelagic productivity 10-year program, and also there has been some talk about needing to incorporate deep sea exports. When should you call us? One thing we do have some uncertainty about is what is the capacity on ocean sites, power capacity, longevity, data capacity for including equipment on that. So I think if we had a clear set of design specifications that would really help the biological community understand how they could engage better with the ocean science platforms. We can also provide links to the broader scientific community with expertise on biological ocean monitoring through GOOSE, through MBON, and also through endorsement of best practices. We'd like to think that you would be wanting to call us because you'd like to increase the valuable data which is coming from your platforms. And we are quite well connected in the biological areas with some of the major international conventions, including the CBD and the SDG and the biological components of the UNFCCC. With that, I will stop and thank you for your time and good luck with the meeting.